Hey guys, welcome back. This is the second video from our ACID playlist. In the previous video, I have discussed on how exactly the write happens at a database level, and we deep dived into atomicity. What is atomicity? With an example how atomicity database ensures either all the instructions are executed or none. The very much important thing is you need to watch the previous video. Why? Because in that video, I have explained how exactly write happens into the database. In this video, we would be discussing on the consistency. What exactly consistency means? Consistency means managing data integrity. There is certain set of constraints that me as a owner of that particular database, I have set certain constraints, and that constraint should be followed. And when every single instructions, every single row that I am adding into the database, if it is following that particular instructions, means I can say like, hey, my data is having an integrity. Let's take an example. There are two tables, employer table and employer table. Employer table is a parent, employer table is a child. So there is a parent-child relationship. Insert into employer table, the name is Raju and employer is Google. So if there is an employer, the employer might be working with some kind of an employer. So this is a parent-child relationship. And again, like, don't take this SQL instruction to be syntactical correct. The ultimate purpose for me to explain is what exactly is the meaning of data integrity. Insert in an employer table a new employee called Raju who is working in Google as an employer. Employer table is there. Both the rows are present, Google and Microsoft. Google is an employer 1, Microsoft is employer 2. Employee, Ram, Raju and Shyam. Ram, employee 1, working with Google. Raju, just now we have inserted Raju working in the Google. Shyam is working with Microsoft. The important thing is whenever we are inserting an entry into the child table, we always need to check whether the parent is present or not. That is what the foreign key or the referential integrity is what we generally talk about. Whenever I am inserting a record into the child table, the database have to ensure like the corresponding parent entry is present. If the parent entry is not present, it can't insert the child record into the database. This is a valid example of a data integrity. Let's take an invalid example. Assume like database is not following a data integrity. Insert into employee Arnav, employer is Apple. So in my employer table, there are only two employer, Google and Microsoft. There is no Apple. Employee I am inserting. Ram is present, employee 1 with Google, Raju with Google, Shyam with Microsoft. Arnav, if let's say database is not doing a validation, if let's say it is not following these integrity standards, if it is not following the constraints that I have set, in my employee table, I am inserting Arnav. But who is the employer for this? So what would happen? So let's say someone is firing a select query and they are saying, hey, give me all the employees and its corresponding employer. Ram, Raju, Shyam, I have all the employers. What am I going to do with Arnav? There is no employer associated with the Arnav because there is no entry present here in the employer table. This happened. So now my data integrity is lost. So for some records, I am able to find the employer. For some, I am not able to find the employer. So now my data is corrupted. My data is inconsistent. That's the reason the integrity is important. If I am having a constraint, if my integrity, if ACID property is followed properly, then this validation happens. And if only and only if the parent entry is present, then only the child entry is allowed to be inserted, else it is not allowed to be inserted. By ensuring this constant validation, I am 100% sure like my database data is correct, it is not corrupt, it is having all the fields. So whenever I am pulling, I would be exactly getting the similar kind of a response for all the rows, and there won't be any kind of an inconsistent data that I would be getting from a database. This is what about consistency that I wanted to explain. Now let's discuss on how consistency is actually achieved. A valid example that we are taking. Insert into employer Raju, employer Google, it is a valid use case. Transaction T1, entry into the val file. Again, important thing is you have to watch my previous video from starting portion to understand how exactly insertion happens in the database. Transaction T1 started, entries into the val. Then there is an executor engine that gets invoked. That executor engine, its job is to validate the constraint. So it is checking, hey, check employer Google is present. If the condition is valid, it will insert the entry into the val file and it is going to do an fsync val to the disk, and then commit happens. So basically what is important for you to understand is there is a component called executor engine. It validates all the constraint. It can be not null constraint, unique constraint, what all different constraints are there. It is going to validate to ensure like, hey, whether data integrity is maintained or not. If everything is correct, in this case the Google employer is present, it checks that everything is good, the transaction is completed, and the commit message written onto the val file, and it is fsynced out to the, like, it is burned onto the disk, and then the commit happens. This is in the valid case. Let's check an invalid use case. Insert into employer Arnav, employer Apple, it is an invalid use case. Same thing, transaction started, entry in the val file, executor engine is invoked. Now what executor engine is doing is basically it is checking employer Apple is present. In this case, Google was present, it is a valid use case. In this case, Apple is not present. It is going to issue a rollback statement. If you remember, in my atomicity, I have added that abort instruction in my val file. There can be any error when I am executing my statement, yet my transaction is not completed. Executor engine is there, it is validating, hey, there is some constant violation is happening, so I should not be burning this information onto my disk. It is issuing a rollback statement. In memory value is getting changed. The transaction manager is going to roll back this particular transaction, and abort message is added to the val file. Val file is burnt onto the disk. The database it is going to see, hey, abort instruction is present, so I should not update anything. So now my data integrity is still maintained. I am not adding Arnab as an employee to my database. This is how consistency is achieved. One important thing before winding up on this consistency topic is, there has always been a misconception between CAP versus ACID. So in CAP also there is this consistency. CAP consistency, availability, partition tolerance. This is a consistency. And in ACID, atomicity, consistency, isolation and durability. This is again a consistency. Most of the people generally, like around 90-95% of the people are confused like this and this consistency are same. What is actually meaning of consistency in the CAP? It is used in the distributed systems. Assume there is a Cassandra. It is a NoSQL database. It doesn't matter. It has multiple nodes. Okay. This is N1, N2, N3 and N4. Assume this case. When I am saying consistent, let's say I am updating a balance from 500 plus 100 equal to 600 is what I am trying to do. When I am saying consistent, this database should also, this node should also have 600, this should also have 600, this should also have 600 and this should also have 600. All of my nodes should have 600 means my data should be consistent, should be same across all the nodes. This is the meaning of consistency. Integrity check here is not being handled by the database, it is handled by application. In the ACID, see, consistency means it is maintaining the integrity, it is not ensuring like whether the data is same or not. In the distributed system, CAP, consistency means the data should be present and it should be the same across all the nodes. But in ACID, it maintains the integrity. Integrity plus consistency. Here, integrity is being maintained by application and this is being maintained by database. And this is for case of CAP. And in this case, in ACID, integrity is maintained by database. This is for ACID. So this was a subtle difference between consistency in CAP and in ACID. I hope so with this particular video, I was able to add some valuable information to you, how exactly consistency works internally. Now in the next video, we would be looking into isolation in depth again. If you feel I have added some valuable information, please do consider liking this video, subscribing to my channel for such kind of in-depth engineering concepts, and comment if you feel like I have added something wrong. If you want to appreciate, if you want to correct me, perfectly fine. I'll respond to your comments. Thanks for your time.